Okay, so now I'll take your task 7 also. Yes, again. So basically, yes. So basically, task 7 is of you is of dimensionality reduction. Okay. So objective in this to reduce the dimensionality of a data set for visualization. Okay. So this notebook also include two projects. First is dimensionality reduction with PCA, which is principal component analysis, and second is stock price prediction using time series forecasting, which is ARIMA model. Okay, so now first we'll see the part one, which is dimensionality reduction using PCA. So three concept we'll use in this. First is what is dimensionality reduction. This basically reduce the number of input variable while preserving important information. Second is principal component analysis, PCA. Okay, so this helps to identify key features that explain most data variants. Okay, and third is your data visualization, which convert high dimensional data into a 2D representation. Okay, so basically this three concept we have to use. Okay, so in this also step one will be same, install and import required libraries. Step two is load and inspect the data set. Okay, so in this high dimensional data set you have to use, okay, which contain four features like sepal and petal with length like this, and dot shape to display rows and column count. Okay, then you have to apply PCA for dimensionality reduction, okay, to reduce data set from 4D to 2D. Okay, so PCA, okay, so this n components equal to this will reduce the data set to two dimensions for visualization. Okay, and then you have to convert to data frame for visualization. Okay, so this is how you have to do. Now you have to, step 4 is your, you have to visualize the reduced data. Okay, so by using scatter plot you have to visualize data clusters in 2D space. Okay, scatter plot you know how to plot. Okay, so by using scatter plot you can show it. Okay, now we'll see the part 2, which is your stock price prediction using ARIMA. So in this also the concept will use, first is time series forecasting, which is you have to predict future stock prices using past trends. Okay, and then second will use ARIMA, which is auto regressive integrated moving average. Okay, so in this AR, which is your auto regression, okay, this will uses past value. I is integration, which is differencing to make data stationary. Third is MA, which is moving average. This will adjust based on past prediction errors. Okay, and the third is feature engineering, which create lag features. Okay, means previous day stock prices. So this three concept will used in this. In this also step one will be your same, install and import required libraries. Then you have to load and inspect your stock prices data set. Okay, and then step 3 is your visualize closing price trends. Okay, so by using time series line plot, you have to use time series line plot. This will display historical stock price trends. Okay, then step 4 will be your create lag features. Okay, lag feature, here lag feature shift 1, this will use previous day price as a predictor in this. Okay, so this is how you have to do. And then step 5, you have to train ARIMA model. Okay, so ARIMA 212 here, this will use auto regression, differencing and moving average. Okay, and here forecast, this is step equal to, means next 10 days, this will predict 10 future stock prices. Okay, so this is how you have to do. And then step 6 will be, you have to visualize prediction versus actual. Okay, you have to compare forecast versus actual price. So basically this is how you have to do. In this also the two projects you have to do. First is your dimensionality reduction with PCA, and second is stock price prediction using time series forecasting. Okay, so I hope your task 7 is also clear to you what you have to do. So is it clear?
Yes, yes, ma'am. Thank you.
Okay, okay, no worries, no worries.
Ma'am, if you have some time, could you please guide me like